So section P2, we start to talk about slope a little bit. And like I kind of introduced calculus to you when I was talking about what calculus is, and then I gave you the little example about driving speeds and things like that. Calculus is the study of change. And slope is a rate of change. So we're going to be spending a lot of time in this class talking about slope. So slope is a measure of how many units one thing changes compared to the 1 unit of change of another thing. Miles, how many miles per 1 hour? How many feet per 1 second? Okay? So that's what that definition is supposed to mean. So, as I said, slope is a rate of change, calculus is a study of change. Everything comes together with, we're going to be studying slope a lot. That's pretty much all we do this entire class. All right, so how do we calculate slope? How do we calculate slope graphically when I'm giving you a graph? Yeah, rise over run. You count, right? Count the grid lines or something. So count grid lines. Rise over run is how you learn it in Algebra 1. In words, not rise over run. In words, what is the slope? The change in y. What? Divided by the change in x. And algebraically, we have an equation to calculate the slope. What is it? It's an equation. It's an equation. M equals y2 minus y1 over x2 minus x1. Good. Believe it or not, we're going to be using that all year long, just in a slightly different format, that equation. We will be using Greek letters a lot in this class. You've been introduced to some. They're just Greek letters. They're different letters than our letters that we typically use, and that's why we use them, because we kind of ran out of our letters, so we had to go to somebody else's alphabet. Okay? Typically, Greek letters are used to designate angles, but sometimes Greek letters are used for other things. So, in math, the Greek letter delta, this is capital delta. There's a lowercase delta also. Capital delta looks like a triangle, and it represents the phrase change in. So, if I were to write delta y, that would mean change in y. So like up here, instead of writing change in y, I could write delta y. And here, instead of writing change in x, I could write delta x. And that is your first little piece of calculus notation, right there. Right? Yeah. So we are doing, this is what we're doing right here. Change in y divided by change in x, but you're going to see delta y divided by delta x. And we'll even get more lazy than that. Instead of drawing a triangle, because my triangles are pretty sloppy, we're probably going to go with a D. And the D is going to represent delta, which represents change in. And we're going to have just dy over, dx. That's an x. dy over dx. This right here is calculus notation. You're going to be using that all year long. Okay. Some other Greek letters for you. A lot of these get used in math or engineering or science, like I said. Probably you know this one already. Probably you know that one already. What's that one? Theta. This one is and no. Gamma. Yep. These are the capital Greek letters up here. They correspond to the lowercase Greek letters down here. And I can tell you with certainty in mathematics, if you go into college and you get into higher levels of math or engineering or something like that, you're going to use alpha, beta, theta, gamma for sure for angles. You're going to use this and this in engineering. You're going to use this in upper level math classes. Calc 4 uses lambda. Let's see. Nu has a special meaning. Mu has a special meaning. This is lowercase delta. It has a special meaning in mathematics. Every single one of these. Rho is density in science. every one of these has a purpose. We use this guy also in engineering. It's another angle that's typically used. So a lot of these letters get used all the time. We know this one. We are going to use, where is it? Where's my sigma? There it is. We're going to use this one. You've used it in Algebra 2 before. Let's see. This one has a purpose. 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 This one does too. So they're all over the place. It's good to know them. So in math, uppercase Greek usually indicates an operation like sigma, the summation operation. Lowercase Greek is usually some sort of angle or some specified constant quantity. So that's what we're dealing with here. Just don't be afraid of them when you see them. Don't freak out. It's just a letter like a variable. It's used a little bit differently, but yeah. Okay, find the slope of the following lines. How do we do that? Rise over run. So the slope of this line, if we go in here and find some easy points, let's see. Oh, I don't know. There's no easy points. So now what do we do? Yeah, skip it. Let's go on to something different. So we have, it looks like about 2.5 right there, negative 2.5 on the x-axis. And over here, maybe about 0.5 on the y-axis. All right. So we would use what? Since we can't really do rise over run very well here. Do change in y over change in x. So our change in y was 0.5, and our change in x was negative 2.5. And then you would simplify that down and you'd have your slope. Sorry, not negative 2.5. Change in y was 2.5. Change in x was 2.5. Simplify that down. 1/2 divided by 5/2. (2.5) is 5/2. 1/2 times 2/5. So the slope is 1/5. Okay? On this one, hopefully it's a little bit easier. I got an easy point there, an easy point there. We can totally do rise over run. This one's going to be what? Negative 5. Good. The slope on this one? No? Undefined? This is no slope. There's no slope to the floor. It's flat. This is flat. No slope. The slope is 0. Here we have an undefined slope. It's a cliff. You're never going to hit the ground. You're just going to fall forever. Okay? This one is undefined. It is very important that you remember these. Positive slope, negative slope, 0 slope, undefined slope. It's been important since Algebra 1, but it's very important now. We're going to work with this guy quite a bit in this class. So let's try to recall some of the stuff that we learned. Slope-intercept form. What's the equation for slope-intercept form? Y equals mx plus b. When should we use slope-intercept form, aside from when we're told to? Graphing. When you're trying to graph it. Or maybe you're given a graph and you're trying to generate an equation from it. Then slope-intercept form is extremely useful. What about point-slope form? Okay, I got y minus. That's the first correct thing I heard. y1 Good. Okay, so when should we use point-slope form? When we're given a point and a slope. When else should we use it? You can use it when we're given 2 points. Use it anytime you can. Point-slope form is way easier to come up with than slope-intercept form if you're given 2 ordered pairs, or 1 ordered pair and a slope. So use point-slope form. A lot of times we'll be given problems that say write the equation for the line. You can use point slope form, plug in exactly what you know, and be done. That can be your answer. You don't have to simplify it down unless it specifically says to. How about standard form? What's the equation for that? Okay, and there's some rules associated with that. We're not going to go over those. Hopefully you remember them. When should we use standard form? Never? There's times. Whenever you have to. Whenever they tell you to. Yes, whenever they tell you to, that's when you want to use it. Otherwise, generally, you're going to stick with these. That's not entirely true. I can't get into when we use standard form in this class because you don't understand why. There are times when standard form is appropriate, but for right now, we're just going to put a question mark on there. General form. Anybody know that one? Yes. Everything is on one side. And when would we want to use that? Why would we want it to be equal to 0? Yeah, if we're solving. And there's other times too. So I'm going to put a question mark there. There's other times in calculus when we want it in that form. All right, the little symbol that we see at the top is what? So when are lines parallel? Same slope. And we could probably say something else with this. Parallel lines never cross as long as they're in the same plane. They never cross, then they're parallel. Okay? They have to be in the same plane though, because you can have parallel lines that are not in the same plane, or lines that never touch and are not in the same plane. They're not parallel. They're skew. Okay? When are lines what? Okay, when are lines perpendicular? Slope is opposite reciprocal. When else? Like what else can we say about perpendicular lines? 90-degree angle, okay. There's a word that you might have learned last year. Starts with an O. It's a long word. Orthogonal. Yeah, that's another word that we use for perpendicular. It's orthogonal. All right, let's write the equation for the line passing through these two ordered pairs, and then find the equation of the line through one that is parallel, and then another one that is perpendicular to the original line. This is a skill that's good to have. So, write the equation for the line passing through these two ordered pairs. We should probably do that first. Let's do that. What do we do? Jump right into point slope form. No. We need something first. We need to find the slope first. So m equals what? So 8 minus 0 is 8. 2 minus 5 is negative 3. So my slope is negative 8/3. Yeah, it's a good one. Now what? Okay, so point slope form. We have y minus which point do you want to use? 5, 0. Y minus y1, it just turns into y equals our slope, negative 8/3 times x minus 5. Is that an equation for the line passing through those 2 points? Yep. Didn't say slope-intercept form, so that's good. You might put it in slope-intercept form down the road, but you don't have to here. Now, we want a line that is parallel to this line and perpendicular to this line that goes through this point. Guess what? Point slope form again. Here's my parallel line. What am I going to write? For parallel, negative 8/3. X minus 1. Done. For perpendicular, Done. Okay? Way easier than any of the stuff you ever did in Algebra 1 and Algebra 2. It doesn't specifically say, so we can write our answer like that. Don't waste your time with all the other stuff. All right, little practice here. Why don't we just talk me through it? Find M, okay. It's right there. Equals. Point slope. All right. What do we got? Okay, we're using the second point. Equals. Is that a good answer?
Yep.
Okay. Now what? Okay. And perpendicular. We done? Okay, so we're done.